So as you might guess, these are some examples of games. These are a couple of examples of games that people made in this class the last time I taught it. So one was kind of a silly, interesting, but interesting from the point of view of game mechanics, not great in terms of graphics. This game is beautiful graphically, and really simple gameplay. The goal is just to stay alive. And if you don't like those kinds of games, well, there's many options, but some of them are just very simple games that are beautifully executed. This is one that I don't actually understand, but I just love the sound of it, and when you actually make some kind of something happen, it's satisfying. Okay, so these are examples of games made last time I taught this class, and there were hundreds of students then, so there are hundreds of examples like this. Those are some of the more interesting ones, and they're the kinds of things that you can expect to be making or be able to make in a couple of weeks. The reason that I'm showing you those now, and I'll probably show a couple more in the next class and so on, is that I want you guys to start thinking about what it is you would like to do with Pygame. So we'll use Pygame to make games like this, sort of 2D games, but very rich, very full-featured. There's music, animation, sound effects, interaction with the mouse or keyboard, however you want to do it. But you can't just, when you start on one of these game projects, you should have some final goal in mind, and now is the time to start thinking about it. So keep that in mind in this class and in the next few classes. Okay, so before I begin the lecture proper, does anybody have any questions for me? Yep.
When you install the modules for Pygame into Python, it shows you how many you installed. Is there a way to see what was installed and what they do?
I don't know. You could look around in the directories that hold all the Python files. But I mean, a better place to look for what Pygame can do is the Pygame documentation that's online. And still, the way we'll start projects in this course is there'll be sort of a standard template file that I'll start with today that sets up sort of the default screen and game, and you build from there. And usually you kind of, you try and do it in a way that there's something you want to add to your game, like music or images or some fancy collision detection. And so what you'll do then is just start Googling Pygame wave file sound effects or Pygame whatever music, MP3 music, these kinds of things. And that's basically how you discover the features of this thing. So I'll go over some of the basic features today. And then the next couple of lectures will be me creating a game here in front of you. That's how we'll learn some more of the features. And then after that, it's sort of self-directed. You have things you want to have in your game, and you want to figure out, can Pygame actually do those things, or is it not possible? Mostly anything that is 2D graphics is possible in Pygame. 3D graphics are not there, they're not available. You can kind of fake them if you want by, you can draw anything in Pygame, so including 3D pictures, but it's not the easiest way to get 3D graphics. Okay. Other questions? Okay, so this is a big departure in this course. Things are going to be quite different now, in the sense that we're going to be starting to work on bigger things, so projects that last more than one class, more than one lecture, and for you that means you'll be working on bigger programs. And I've mentioned this before, but it's worth saying again. The key thing to do when you're working on a program like this, particularly if it's a one-person project, is always have something that works. It may not do all of the things you want it to do, but whatever it does should be working. So don't have something that doesn't compile. Don't have something that just crashes constantly. Always keep something that works. And if that means that you reach a state where you've broken it so badly you can't fix it, save some backup copies and go back a version or two to something that did work, and go back to that. Don't just forge ahead with a broken piece of software that you'll never get working. Okay, so there's a game template file that's you can download from the notes from today that does this. So let's look at the features of it. There it is. That's the game. It's a blank screen. The way you win the game is you quit by clicking the X button. Okay. So that's the thing I want you to start with. That, at least, is a working program. So everything that you do, every game that you make, will start with that, and at least right now it's working. It does what it's supposed to do, which is not very much, but that's okay. So let's take a look at the code for that so-called game. And we'll walk through it a little bit, because you should know the basics of it, because you're going to be working with it. And for that, I'll just walk you through it. So the strategy that we'll use is, games tend to have a lot of things in them, a lot of state information. So, there's usually things that are moving around. Maybe there's bullets. Maybe there's a guy with a hand waving and running back and forth. Maybe the screen is rotating. All of these things are sort of state. And it's sort of a large collection of different pieces of stuff. And we'll see that there's even sort of resources that you need, like things like images that you loaded or sound files that you loaded. And we want to keep those together in one place. And we've seen that we can make objects that store stuff. So our games will just be in a class that's called MyGame. And that class will be a convenient place to store things. In particular, anytime we want to store something sort of persistently, we'll just introduce it as a variable that will work with, will access by saying self dot whatever the variable name is that we want. So when you create one of these new games, so like all objects, it has an underscore init underscore method. This is stuff that we load if we want music or sound, which we will want later. Don't worry too much about what it is exactly doing. It's basically setting up whatever it needs to do to play sound. Basically the sample rate and a bunch of parameters to do with that. I can't even claim to remember what it does. I copied it off of some Pygame example 10 years ago, and I'm still using it today. We have to load the Pygame module. Hopefully many of you have installed that. Some of you have even done some work with it. So we import that, and sort of one of the first things we have to do is initialize the Pygame module. That starts up a bunch of stuff that Pygame does internally. Now we want to have a game that's played in a window. We'll pick the width and height of that window. 800 by 600 is a decent, it's sort of a decent size for medium to low resolution monitors. For example, I wouldn't go much bigger even on, let's say, the display that I get out of this, this projector here. It fits and it works reasonably well. And so these few lines of code here, they pick the width and they pick the height. They're just saving it here. That's just saving it as variables that we can access later. And then we use this function pygame display.setMode, and it tells us create a window with this width and this height. Now, one of the things that we'll sort of get used to with Pygame, and it appears in a lot of other types of programming, is what's called event-driven programming. So what you've done so far is typically you write a program which executes some instructions in order. Maybe there's some if statements, maybe there's some function calls in there, but your program is executing and happens sort of one line at a time. And even when we ask the user for input, well, we just call this input function, and that function is executing, waiting until the user presses enter, and then your program returns. It immediately continues to execute after that line of code. When you do things like graphical user interfaces and games, there's a different style of programming that you do, and it's called event-driven programming. And the idea with event-driven programming is most of the time your game or your computer, your piece of software that has a graphical user interface is not doing anything but waiting for the user to do something. Or it's waiting on something to happen, often the user, sometimes it's something external, but it doesn't need to do anything, it doesn't need to be computing anything, it doesn't need to do any work, and doesn't need to use your computer's resources. So in event-driven programming, what happens is your game just says, okay, I'm not doing anything right now. I'm handing over my time on the processor, on the CPU, to the operating system, and I expect the operating system to tell me when something interesting happens. And that's what you get, an event when something interesting happens. Maybe the user moves the mouse, maybe the user presses a key, and what happens with us when we do games is we're typically shooting for a game that has some animation in it, like the games that you saw. And the way animation works, at least with PC games, if you're being nice to other things running on the PC, is you decide what kind of display rate you want. How many times per second do I want to update the display? And a sort of standard thing is 30 frames per second. That's a movie thing. 60 frames per second makes cleaner animation. But 30 frames a second or 60 frames a second, that still leaves a lot of time between frames, right? So 30 frames per second, you have about 333 milliseconds between frames. When you're not drawing a frame, you're not doing anything. That's a lot of time that you don't need the CPU. Other things on the computer could be running, so you hand that back. And so the way we set that up here is we define an event, which is, we're just making it here, we're creating it, it's called the refresh event. And what happens is every 333 milliseconds, a refresh event is going to come that's going to be for us to handle. And the way we handle a refresh event is we realize, okay, a frame, 1/30th of a second has elapsed. It's time for us to draw the next frame of whatever animation we're doing. So these 3 lines of code here, they just set the frames per second rate. They create a new event type that is just for these events, these refresh events, and then they set a timer that will, every 333 milliseconds, will send us one of these refresh events. Okay. And then we hand it back to, we basically hand it back to the operating system. So we say, okay, at this point, we have nothing more we want to do right now. We'll just wait for events to come. So that's the init method, and the last thing it does is it calls this event loop method, which I'll show you in a second. But the event loop method just sits there waiting for events to happen. Here's what it looks like. So we just loop forever, waiting for something to happen. We ask Pygame to give us one of these events. That's with pygame.event.wait. And whenever that's ready, we get this event. And in this case, in this particular example, there are 2 kinds of events. And these are the quit event, which is something that's generated by the windowing system when the user does whatever it is they're supposed to do to close the window. So in my case, there's a little X icon in the top right corner of the window. The user clicks on that. That generates a quit event, which we get here. So we get an event. Its type is pygame.quit, and we handle that by calling sys.exit. Just exits the whole program. Okay. And the other kind of event that we handle is the kind that we generated ourselves, which were these refresh events. And to handle one of those, we call self.draw, which is another method that we have down here. Okay. And any other events we don't do anything with. Okay. So you might be curious then, well, what are the various kinds of events? So this is where Google is your friend. So just Google Pygame events, and you get a bunch of functions that have to do with dealing with events. And here are some of them. There's a quit event, there's an active event, there's a key down event, a key up event, a mouse motion event, a mouse button up, mouse button down. There's some events that have to do with joysticks, which seem cool, except don't use them, please, because whoever's testing your games won't necessarily have a joystick, so that's not so helpful. And there's events that show up when the user tries to resize the window, or where parts of the window are shown or not. Those we won't really deal with. And then there's these other events that start at user event +1, user event +2 that you define yourself. Okay, so let's see about handling another one of these kinds of events. Let's say the key down event. So let's look at if event.type is pygame.keyDown. Let's just try something silly and print it just to see what it looks like. Okay, so I'll press a key, H, and it says a key down event occurred, Unicode, H, key 104, mod 0, scan code 43. So there's some information, and then I hit other keys, and all these events show up here. Okay. So going back to the documentation, we see that the keys actually have names that you should use. And they are K underscore something, and the sort of kind of standard 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, colon, semicolon, less, equals, all of that stuff, and all the letters of the alphabet as well. And there's even an escape key. So let's say if the event.type is pygame.keyDown and the event.key is equal to pygame.k underscore escape, then we won't print the event, but we'll do sys.exit. See if that works. Okay, so now I've made it possible in case I get panicky and I'm playing this game and my boss comes in when I'm supposed to be working, I can just hit the escape key and the game goes away. Okay. So this is us now handling this event that occurs when the escape key is hit, and the way we handle it is the same way we handle the system asking us to quit. Yep.
Notice that some of your event dot things are small letters and some of them are big letters. Is the 100% big letters what's going on in Pygame, or what's the small letters is what's going on in your
You mean these things here?
Yeah.
Okay, so the
and then event dot key down in capitals.
yeah, so there's a sort of convention in Python and a lot of other programming languages that if you have numbered constants, so just variables that are constants and they're usually integers, then you write that as a name that is all uppercase. Okay, so pygame.quit is actually a number. It's, I don't know, 103 or something. And but of course, it would be much harder to read this if I wrote event.type equals 103, and you were supposed to know that that means it's a quit event, right? So it's just a name for a particular number. So all of these uppercase things, that's what they are. They're just numbers that are defined somewhere. We've given them names that we can read so that we don't have to remember a bunch of different integers. But these things here, like event.key, well, event is this thing that we get back. It's an object that we get back when we ask Pygame for an event. And if the event type is a key down event, then it has a property called key. And we saw when we printed that event, I think we saw that. There it was. It actually has several properties, like it has a Unicode property, it has a key property, it has a mod property, and a scan code property. And I think we could look what those things mean. Yeah. So these mod properties, for example, they might take on any of these values, actually an XOR or an OR of these values, where if the user is pressing the left shift key at the same time as they're pressing this key, then we get some special, we can read that off of this thing. If they're holding any of these other magic keys down, left shift, alt, control, any of those things, we can read that off of here. So there's different things. The properties that an event has depend on the event type. In the case of a key down event, the main thing is the key. Which key is the user pressing? But there's other things associated with that too. Okay, questions? Easy so far? All right. So we're sticking with with the plan, which is we have something that is working. It's not doing much, but we just added a feature, which is another way to exit the game by pressing escape, and that's working, so we're happy there. Okay, and whenever we receive this refresh event, which happens 33 times a second, and we can check that if you like. So what we'll see here is these refresh events just happen continuously as soon as we start. Then we call self.draw. So let's look at self.draw. Self.draw is supposed to update the display. We can already guess that there's not much going on there because all we see is a blank white screen. But something is happening. So what happens in this draw method? Well, we define a color called white. And colors in Pygame are just triples of integers in the range 0 to 255. These are the red, green, and blue values that make up that color. You can find many tables of these things online. So this color 255, 255, 255 is maximum red, maximum green, maximum blue. You combine all those together, you actually get white, okay, in an additive color model. So we just call that thing white, but it's really just a triple of integers. And remember, we have this self.screen that we got here when we set up our display. That's in the init function. And we say, well, fill the screen with the color white, this color that we just defined. Okay. And then there's this funny thing that says pygame.display.flip. So what is this doing? Well, it turns out that when you do video games, or when you do basically any kind of animation, think about what happens when you're in one of these draw routines. Like in one of those games that we saw, there's a background, there are spaceships, there are rockets, things moving around, and those all have to be drawn for each frame. And they get drawn, maybe the rockets get drawn first, and then the spaceship gets drawn, at the end, or maybe the background gets drawn first, then the rockets, then the spaceship, then some other things. I don't want to see all that happening, right? As somebody who's playing the game, I don't want to see, oh, this thing gets drawn, and then this thing gets drawn, and then this thing gets drawn, and then this thing gets drawn. So what Pygame does is it uses a technique called double buffering, which you can think of as like a sheet of paper. So the draw routine is drawing on the back of the paper, and it draws the missiles, and it draws the rockets, and it draws these things one at a time. And then once it's all ready, you call pygame.display.flip, and in one cycle of your monitor, it displays the whole thing at once. So you don't see this stuff, it's there and then it's not there. It just all appears at once. And then the next time it's going to draw, it's drawing on the back side of this paper that you can't see yet until it calls pygame.flip again, and then you see everything again. Okay? And that's how I can go from a page full of stuff to a blank page instantly, and then back to a page full of stuff instantly. Okay? So that's what that does. You don't have to worry too much about the mechanics of that, except that your draw routine will always look like this. You draw a bunch of things, which is not really doing anything yet. The user's not seeing it. And the very last thing in that draw routine is the display flip, which suddenly reveals everything that you've just drawn. It takes gets rid of whatever used to be in that window and replaces it with all the stuff that you just drew. So that means you need to redraw things from basically everything from scratch at each frame, at least the way we'll be doing things in this course. Okay? Questions there? So the best way to try and understand something is to change it. So for example, let's change that definition of white and see what effect that has. And indeed, now the thing turns yellow because I've changed this to maximum red, maximum green. When you combine those two colors, you get yellow. Okay. All right. So for this class, we're not going to make anything super exciting. There's just a few of the sort of fundamental pieces of Pygame, or the things that you kind of need to have in order to get anything done. So I'll just be demonstrating some of those in this class, much the same way that if I was teaching you, I don't know, if I was teaching you how to do carpentry work, or woodworking, the first few things I would show you is, how to use the various tools in the shop without chopping your fingers off, and then maybe do some trivial thing like spin a round dowel or something, like the simplest sort of wood thing you can make. So that's what we'll do today, is a little bit of animation, a little bit of testing out the ways of dealing with events, and how we do that. So let's start with something easy. So let's make it that, in fact, it's a feature we saw in one of these games, or a similar feature, that the user can press a key and the background color will change. So if we want to do that, what are the things we need to do? Yep. Okay, so we'll need to figure out the colors that it will change to. So maybe instead of always filling the screen white in this draw function, we should instead keep track of a background color. And we'll initialize that when we start up. Let's maybe do that here. So we start with white. So this doesn't do anything yet. It hasn't changed anything yet, but at least it still works, and it's moved the code around a bit. But now we have this variable that's keeping track of what color our background is. We want that when the user presses a key, that changes. So where do we insert code for that? So what do we need to be looking out for? Yep. Yeah. So we're interested in a particular event, and that event is the user hitting a key. And when the user hits this key that we're interested in, then that's what we'll do. We'll change the background color. So in our event loop, this is where we handle all of these events. So we handled a key down event with the key pygame.kescape, but let's handle C maybe for color. Okay, check if that works. Okay, so that we're now seeing when the user presses C, that code is executing. But what do we want to do there? Well, we want to change the background color. And I don't, right now, feel particularly like making a long list of interesting colors, so let's just do something random. Let's say self.background color is equal to random.randrange 256. So we'll just pick a random triple of integers between 0 and 255. And that's how we do that. Okay, so I press C, and the color changes. Press it again, the color changes. Okay? So a couple of things happened. We've created some extra state for our game, which is the current background color, which we introduced a variable to save it called bg color, and it's associated with our game, so we access it with self.bg color. And then when we process a key down event, all we have to do is change that color. We don't have to draw the screen again. We don't have to do anything like that. The next time the screen gets redrawn, it gets redrawn with this new color. So notice when we process this event here, this key down event with the key C, we didn't do anything but change the value of that variable. Later the drawing routine draws using that new color. It does mean that there's going to be 1/30th of a second delay between the time we press the key, or potentially up to 1/30th of a second from the time we press the key till the color changes. But that's okay for us. We're willing to accept that. Okay. Good. Questions? All right. So sort of fundamental to these kinds of games, at least, is being able to draw stuff, which we haven't done yet. We've only really filled the background with a solid color. And to make these games good, or at least nice looking, the things that we usually draw, they're actually images. So one of the things that you will have to do in making your game is find images to put in your game. Okay. And there's a really useful tool for that you may or may not know about. And this is it, Google Advanced Image Search. How do you find Google Advanced Image Search? Well, you Google Advanced Image Search. That takes you there. And you get this really big form. So I was interested in images that have to do with Python. And there's lots of other, fancy ways you can search. That's fine. So if I just do that, that's just a standard image search, I get something like this, which is nice. There's some very beautiful images of pythons here, but these are not something that's that useful for me to use in one of these games, right? There's a whole bunch of problems with them. One of the main problems that I see here is, well, they're pictures of pythons in the wild. There's all kinds of background around them, not particularly helpful. If I was a pro with Photoshop or something, then I could go and really manually erase all of that background so that I'd be able to use these. But even then, it would look kind of weird to have and generally in these games, if you have something photorealistic in them, it stands out and looks weird. So let's go back and see what other things we can do with this image search. So a particularly useful thing is the type of the image. So you can ask for any type, faces, photos, and clip art is a good one. That's usually where you find the kind of stuff that's useful for you. And something I would like you guys to pay attention to is you can also ask about the usage rights. It's probably not going to come up in this course that someone, you make a game and someone sues you because you used some image of theirs that was copyrighted. Unless you happen to make a really good game and distribute it widely, then yeah, it could eventually come back to get you. But it's nice to pick images which someone has said they're free to use and share, if you ever plan on distributing this game. And the clip art is what gives you this nice collection of images, which are much more useful to us now, right? Any of these things is more useful. So this is a good one. In fact, it's the one that we'll use. But oops. Let's look at So the nice thing about clip art, and most of these, so if you notice the image, when it's displayed here, looks a little bit different than it did in the page. So what's different is there's this sort of checkerboard background showing up. Anybody know what that means? Yep. Yeah, so it means it's transparent, and that's usually what we want for our games. Otherwise, if it's not transparent, if it's really a white background and our game is does not have a white background, then what will happen is this thing will be walking around with this white box around it everywhere on the screen. Okay, so I went and got this Snake Python serpent free version. So let's use that one. And I resized it as well because it was a bit big. So it's in a file called python.png. Okay, so we want to draw this maybe in our draw routine, or at least we'll do that now. So this is a file on my computer, and I need it inside my game. So we can Google how to do that. And this is sort of a typical image, or a sort of typical workflow is I know what I want to do, then I pick some Google keywords. Usually the first one is pygame, and pygame image load, and I see, there is a method right there. Pygame image load new image from a file. That sounds like exactly what I want. And there's usage examples. So pygame image load, and then you give it the file name. So let's try that. Pygame.image.load python.png, and that function returns an image. Load an image from a source file, pygame will automatically determine. Yeah, so it gives us this image. All right, so that loads it. What do we want to do with it now? Well, I guess we want to draw it, right? This just loads it into memory somewhere. I guess we want to draw it onto our display. So how do we do that? Well, we Google it. So there's a bunch of stuff, information on tutorials. And you see, okay, there's some function here called blit. Oh, and look at that. The first example is, you can load an image, do what you want. There's examples of how to use it. But the main thing is, we can do the following. So an image, when we load it, it's this box, right? It has a size. So we can ask, what does that box look like? So let's just, for now, get it and print it. So it tells us that this image is, the rectangle associated with this image is 0, 0, 160, 143. So that means that its left side is at position 0. Its top side is at position 0, and its width is 160, and its height is 143. So it's not exactly square. All right, so that's the rectangle that we have, and that's what we want for blitting. So we can do self.screen.blit image and rectangle. We don't need that rectangle anymore. Let's see if that works. So there we've displayed it. Okay. Good. So what's this blit routine doing? Well, its first argument is the thing that I want to display, the image. And that second argument is a rectangle that tells where I would like to display it. And I'm giving it the rectangle that came with the image, which has corner, top left corner, 0, 0, and width 143, height 160. And it displays it up there in that top left corner. Yeah. Everything is in pixels. Yeah. Now, you may have encountered this before, or maybe not. When we learn, let's say, Cartesian coordinates in school, we have these x-coordinates and these y-coordinates. And the x-coordinates, as they get bigger, which direction does it go in? Left or right? So it gets bigger to the right. And the y-coordinates, when they get bigger, which direction do they go in?
Traditionally up.
The Cartesian coordinate system, it goes up. For whatever reason, in computer graphics, the y-coordinates go down. And so 0, 0 is the top left corner. That's why this guy's jammed up here in the top left corner. In fact, the exact top left pixel in this image is in the top left corner of this window. Yep. I don't know why it's that way. Yeah, I mean, it's maybe kind of handy because, no matter how big your window is, it starts at 0, 0. I mean, like up there is 0, 0. It's probably has something to do with the history of, computers being developed in English-speaking countries first. That's probably the only reason, actually. Okay, so 0, 0 is the top left corner. So instead, maybe I'd like to draw this guy center. Not necessarily in the top left corner, but maybe we can center him horizontally. So, I've got this rectangle. Let's move it. And so if you look at the Pygame rectangle class, it has this move method that gives you a new rectangle and lets you move it by some x-coordinates and some y-coordinates. They can be positive or negative. So I'd like to center this thing. Where's the center of my screen? Well, the width of my screen is 800 and the height is 600. So I should be able to do self.width divided by 2, and self.height divided by 2. Is that going to work? So that moves the rectangle so that it's instead of, well, and we'll print it too just to see what it looks like. Yeah, so it moved the rectangle from where it was to its top left corner being 400, 300, which is what we want. Did that center the image? No. What's in the center of our display right now? What part of the image is in the center of the display? The top left corner of the image is in the right where we placed it, right in the center of this 800 by 600 screen. So if we really want to center it, then we have to be a little more careful. We want to push it up by half of the image's height. Okay. So, and the height is in that rectangle. How do we get it out of there? Is it called height? Yeah. So then we want to subtract the rectangle's width divided by 2, and we want to subtract the rectangle's height divided by 2. There we go. Nicely centered. If it's not nicely centered now, it's because the Python is not actually centered in its own image. It could be that there's some extra white pixels at the top of this thing. Okay? Any questions? Nice and easy? Good. All right. So what else might we want in a full-featured game? Well, we might like to draw some text. So usually a game has something like or often a game has something like a score or instructions, and so that means we need to draw text, even if that text is just some numbers for a score. So we need to figure out some way of doing that. But before I do that, let me just point out one thing. We're working on this draw routine here, and this draw routine is this thing that gets called 30 times per second. And inside this draw routine, I've put this code for drawing this image in the center. Now, most of this code is pretty cheap stuff. Adding a few numbers together, a few integers together, that's cheap, doesn't take long, it's fast. But something in here that is maybe not so fast and that maybe we don't need to do over and over and over again is this part where we load the image. The image is sitting on the file on my computer. It's a PNG file, which actually means it's a compressed image. So this image load function reads a file into memory, decompresses it, converts it from whatever the PNG format is into some internal format, and then it's ready to go. And it's doing this now 30 times per second. And there's no reason that we should do this every single time we draw it. We could just load this image once at the beginning of the game, the so-called game, and use it forever. So let's just take out of this draw function the part where we load the image, because we can just load it when we initialize. And self.image. So we'll save that image. Then when we draw, we don't have to reload it every time. We just keep reusing it. Doesn't affect, I mean, you can't tell that anything interesting happened there, but I know, and it hurts me to be doing all of this extra work for nothing. And if we were really, really cared, then even these calculations of figuring out the center, we could have saved all that, but those are fairly cheap. Yeah?
The double backslash operator.
Forward slash.
Oh, that's why I'm confused. Okay.
Yeah. So double forward slash is, remember, it's what? It's integer division. And that's because if we take the width and divide it by 2, and the width is odd, then we won't necessarily get an integer, but we can't ask Pygame to draw it at 401/2 pixels. We have to specify an integer, so we use integer division here. Yeah. Yep. And if we want it to be a little more accurate, maybe save a pixel. This would be a cleaner way to do it. Okay. All right, so back to, so let's say what this is doing. Draw an image of a Python. Now we want to draw some text. Okay, well, to draw text, I mean, up till now, all we did was say print and some text appeared on our screen. But when you're making a game like this with a graphical interface, what's the first thing you have to pick before you can draw a text? What do you need to select? What do you need to choose? It's so obvious that you don't think of it. You need to choose what font to display it in, how big it's going to be, all of those things you need to decide on, because all of that is available to you now. It's not just whatever system font your monitor has. You get to choose, but you also have to choose. So that means we need to know how to load a font. And there's a couple of ways to do things with fonts. One of them is to just ask the system for a font. I'll show you how to do that, though I don't necessarily recommend it. So let's say font is equal to pygame.font. And sort of the easy way to do it is to, not font.font, match font, is to just specify a string that has a bunch of font names in it and hope that Pygame finds one that kind of matches. So give me a font name. Arial. Anything else? In case there's no Arial. Times New Roman. Oh, the worst. Man. Comic Sans. Okay. All right, so we'll load that thing. So that gives us something which is like some kind of font object that describes exactly what every letter and number looks like in this font. I'm not sure what I'm going to get. Hopefully Arial, but who knows? It depends on what's available on the system. But now I need to actually draw something in that font. And for that, you use font.render. And it takes two arguments. One of them is the thing you want to write. And the other one is oh, actually there's a, takes a couple of things. So let's just so there's no mystery here, right? Because you can do anything, so anything is possible, that means you have to choose everything. So I have to choose, the text that I'm writing, whether or not the font should be anti-aliased. Just say yes to that all the time. It looks better. I also have to pick the color of the font, the text that I'm drawing. So I'll choose black in this case. But the font itself needs a little bit more information. It actually needs, I think you have to specify the size of it. So let's try 20 point. String object has no, no. Let's quickly look at an example. Pygame.font.match font. Okay, so match font, you give it the name. Oh, you say whether it's bold or not. You say whether it's italic or not, and it's supposed to give you a path, and then you should use font. Okay. So that's font file. That will give us a pointer to the file if it's available. Then we want to create the font, which is with pygame.font.font. You give it the file name and maybe the size. And now let's see. Okay. Good. Seems to have found it, seems to have created the font. Now we just need to draw it. So here we are. Okay. So we look for the file that contains the font we're interested in. It tries to find some matching thing on the system. In our case, it found free sans, which is not Arial or not exactly what we asked for, but it's what it thought was a close thing. Then I actually have to create the font itself by opening the file, and the font includes the size that I need to create. And then I pick a color, black, and I do a font render, which is, it creates this thing called text. Now, what is this TXT, and what is this font render doing? I didn't see Hello World appear anywhere on my screen. Well, what happened is font render creates an image of the font, of the picture that is the text that you just rendered in this font. What we have to do now is display that image. So this thing here, TXT, will look very familiar because it's just like this image up here that we've drawn already. So it has a rectangle associated with it, and we can draw it or move it around using that rectangle. So then we do self.screen.lit, the text using that rectangle. And indeed, there it is, Hello World up in the top left corner, because the rectangle, of course, was starting at 0, 0, and by default it puts it in the top left corner. If we think that that's ugly, we can say width minus rectangle divided by 2, 0. That will center it still at the top at y coordinate 0, but whoops. Here's what you have to be careful of. In our assignment, we saw this, and I just made the same mistake, or in one of the last assignments. Here I did this rectangle.move, and nothing happened. Does anybody know why? On the last assignment you did, I was trying to drive home this point. So what do you think rectangle.move does? Does it change the coordinates of the rectangle? No, because I just did it and nothing happened to the rectangle. It creates a new rectangle with those new coordinates. So if I want this to have any effect, I have to say rectangle equals rectangle.move so that my new rectangle is, the rectangle that I'm using is this new rectangle. And that puts it in the center there. Okay. So that's how you work with fonts, but I don't recommend that you use this match font routine. And the reason I don't is, well, we saw it here. I asked for Arial and I got something else. It was some free sans or something. It just happened to be available on my system. These things can sort of vary wildly, and they can mess up your game, that lead to unpredictable widths. So what you can look for is, again, Google is your friend for these things. You can look for free TrueType fonts. Because that's what you need, are TrueType fonts. So here's about 26,000 of them. You can download the file for these fonts, some real beauties. It's a file that ends with the extension .ttf, and I've done that already with a font called oneway.ttf. So let's, instead of using whatever the system gave us, let's use oneway.ttf. And that's somehow a fancier font. And instead of going 20 point, let's go big, 36 point. There you go. Still not huge. Okay, so lots of fonts you can download to put into your games. Be creative, and lots of free TrueType fonts that you can use. All right. So far, so good. That's, we can draw pictures that we load out of a file. We can draw text. Let's do something a little more sophisticated, maybe. Let's have our snake. Maybe we can actually have it move, animate it somehow, move it across the screen. So how would we make this picture of this snake move across the screen? So what does that mean for the snake to move? What's that gonna look like in what we're doing? Yeah. Yeah. So we're drawing this thing 30 times a second. And so that means the movement is really going to be one frame, we're going to draw it here. And then before the next frame, when drawing the next frame, we're going to move it a little bit, close to where it was, but not exactly the same place. And then we're going to draw it there. And then the next frame, we're going to move it a little bit more and then draw it there. And then the next frame, a little bit more and then draw it there. And that's going to make it look like it's sort of sliding whatever back and forth or around, or that it's moving in a smooth way. Really, of course, it's just taking little tiny steps at each time. So let's. So that means now that our this image, this snake that we have more state in our game, which is, where is that stupid snake? We need to keep track of it. So let's say self dot image x coordinate. Let's start it at 0. And let's leave its y coordinate to be, I don't know, let's just say 300 for now. Okay, now when I draw the thing, let's not center it anymore. We'll draw it at, we'll move it to image x and image y. Just make sure we didn't break anything. Okay, so there it is. Those are the first coordinates that I picked for it. So again, I have this state now, which is the x and y coordinate of this Python, and every time I draw, that's where it's drawing it. So all I need to do now is change those coordinates, and then next time it draws, that will change. Okay, so let's do something easy. So move the Python. Let's move him 5 pixels. Increase his x coordinate by 5 pixels. So what's going to happen? Yeah. So it's constantly increasing. At every frame, it's moving it 5 pixels to the right, but now it's somewhere over here on the screen, which it doesn't see anymore. So that works, but it's not great. Let's see if we can do better. So the Python, the way we've done it now, we've saved his x and y coordinates, but we keep adding 5 to his x coordinates. So that sends him off to infinity on the right. Let's define a new thing, which is the change in his x coordinates. Initially that was 5. So let's call this delta x. It still does exactly the same thing. Now, if we want to not have this guy run away, what should we do? What should we check for? We should check something against the screen width. So let's see. So back here where we're moving our Python, we should maybe check if he's run off the screen. So if his x coordinate is bigger than or equal to the width of the screen, that's definitely bad. So what could we do to bring him back? And we can set his x coordinate back to 0. Let's try that. So he goes back to that side. It's not particularly smooth. What if instead we just turn him around and send him back in the other direction? How would we accomplish that? Yeah. So we've had this variable called delta x that we set to 5, and it being set to 5 says at each frame we add 5 to this thing's x coordinate. Once we get to the end of the screen, we could set that to -5, and that would send him back across the screen in the other direction. So let's say self.delta x is equal to self.delta x negated. See how that goes. And then he comes back. Oops. Now where is he? He's going off to infinity over there. Well, over there. For you over there, for me over here. Okay, so that says, well, there's another thing we should check here. So if self.imageX is bigger than self.width, that's bad because it means he's going off the right side of the screen. If self.imageX is smaller than 0, then he's going off the left side of the screen. But we want to do the same thing in either case. We want to reverse his direction. So in either case, it works if we just negate this delta x value. If it was -5 and he went off the left side of the screen, then we turn it to 5 and then he'll come back. So let's check that, but let's also make this twice as fast. He comes back. And he comes back. Okay. Notice any asymmetry there? Yep. Yeah, so on one side he just bumps up against the wall, and the other side he kind of goes all the way out. And that comes again from the thing that we've been using as the coordinate is this x value where we draw him, and we're only turning him around on the right side once that x coordinate is off the screen, but that's his left side that we draw him at. So if we want to make it a little more uniform, then the test shouldn't be if it's delta, so we do the change, we do this test, but the test should be if self-image x plus rectangle.width is bigger than or equal to self.width, because that's going to be the right side of where we would be drawing him. If that goes off screen, we should turn him around. There we go. Doing exactly what we want. Okay. Anything else sort of wonky about that? Yeah.
Instead of doing the self-image x plus rectangle width, could you say on the other side self.width minus rectangle width?
Yep.
That also stop it at the tail?
Yeah, you can move you can do this. This is an equivalent formulation, right? Subtract minus rectangle width from both sides of that equation. It's the same equation or inequality. Okay, so that's about time for today. The one thing that we didn't get to do was to flip him to make him walk in the right direction yet. But we'll start next class, making something serious.